This is practice problem number 2 from lesson 12, unit 4. And in this problem, you're supposed to create a second equation so that the system of equations, so this is the first equation, a second equation, so that the system has no solutions. And what that means is that second equation, the graph of which is going to be a parallel line to the graph of this first equation. So the slope has to be the same. If the lines are parallel, the slope will be the same, but they will have different y-intercepts. So they will go through the y-axis at a different point. This equation goes through the y-axis at -4. A second equation, same slope, different y-axis. So let's graph that first equation. So y equals 3/4 x minus 4. So remember that minus 4, that's the y-intercept. The y-intercept is a -4. So I would rewrite this using the inverse operation. And the additive inverse of a +4 is a -4. And that shows you that the y-intercept is -4. Now the slope is 3/4. So what that means is, let's zoom in on this a little bit. So for every unit along the x-axis, the y-axis is going to go up 3/4 of a unit. So the length along the y-axis of a triangle is always going to be 3/4 of the length along the x-axis. So if I go out 4 units, the length along the x-axis is 4 units. The length along the y-axis is going to be 3/4 of that 4 units. Well, 3/4 of 4 is 3. Another way to look at that is just write this as a fraction. An equivalent fraction is multiply the numerator and the denominator by 4. You end up with 3/4. So now you can use this slope triangle to draw several more graphs. So I'm just going to take this slope triangle and slide it over here. So I've moved it 4 units away from the y-axis. That means it's going to get back to the y-axis, I have to go back these 4 units and then go down 3 units. That is a slope of 3/4. So that would be a -3 over a -4, which is the same as a +3/4. And that's going to get me back to -9. So I started at -6. This is -4, -5, -6. And I'm going to go down 3 units, -7, -8, -9. So if I slide that same slope triangle up here, this is still 4 units from the y-axis. So to get back to that y-intercept, I'm going to go a -4 units and then a -3 units. And this is going to end up at a +6. So -4, -3 ends up at +6. I'm going to take that same slope triangle. Now the reason for the slope triangle is that fixes the slope to be 3/4. So it's 4 units along the x-axis, 3 units along the y-axis. So I'm going to now slide that slope triangle down a little bit, but I'm also going to slide it in 2 units. So this is now only 2 units from the y-axis. Well, half of 4 is 2. So I'm going to be 2 units from the y-axis. And I have to move this down half of 3 units. Well, half of 3 is 1.5. So I'm going to move it over here 2 units, 1, 2, and down 1.5 units. So that's 1 and 1/2 right there. So it ends up being at 2.5, which is the same as 5/2. So any of these equations, so if I write the equation for any of these 3 lines, I will have a second equation that has 0 solutions or no solutions with the first line because they're all parallel, but they cross the y-axis at different points. So I can write those equations. The first equation, remember, is y equals 3/4 x plus -3. This equation, same slope, 3/4 x, but the y-intercept is -9. This equation, same slope, 3/4 x, but the y-intercept is a +6. And this equation, same slope, 3/4 x, but the y-intercept can be either written as 5/2 or 2.5. The thing to note here, though, is that the slope in every case is 3/4. So the second equation can be any equation that has a slope of 3/4, so it's 3/4 x. You can put any value in this square that you want, with the exception of -4. If you put -4 in that square, it'll be the same equation as the first equation, and that's where the system will have an infinite number of solutions. But you want 0 or no solutions, so it has to be different than -4. So the difference in the slopes equals 0, so they're not catching up to each other in any way, they're just moving parallel to each other. The two graphs will not intersect. There is no movement towards each other.